Ever wonder what's really happening when you step into an elevator and push a button? It feels like magic, but it's actually a brilliant piece of engineering that we use every day. So, how do these metal boxes effortlessly lift us hundreds of feet into the air? Let's pull back the curtain and find out. Most modern elevators you see in tall buildings are called traction elevators. The name gives a big clue as to how they work. The core idea is surprisingly simple and has been around for centuries. It's all based on a pulley system, just a much more advanced one. Imagine the elevator car you ride in. On the other side of the system, hidden away in the elevator shaft, is a massive block of metal called a counterweight. The elevator car and the counterweight are connected by incredibly strong steel cables. These cables are not just tied together, they loop over a large grooved wheel at the top of the elevator shaft. This wheel is called a sheave. Now, here's the clever part. The counterweight is designed to weigh roughly the same as the elevator car when it's about half full of people. This balancing act is the key to the whole system's efficiency. Think about it, if the car and the counterweight are almost perfectly balanced, you don't need a massive, power-hungry motor to lift the full weight of the car. Instead, the motor's job is much easier. This motor is connected to the sheave. When you press a button, the motor turns the sheave. Because the steel cables have so much friction, or traction, in the grooves of the sheave, as the sheave turns, it moves the cables. When the sheave turns one way, it lifts the elevator car and lowers the counterweight. When it turns the other way, it lowers the car and lifts the counterweight. The motor is essentially just giving the system a little nudge, lifting or lowering the difference in weight between the car and the counterweight. This is why it's so energy efficient. When the car is going up with a lot of people, the motor has to lift the extra weight of the passengers. But when a full car is going down, its weight is actually helping the motor lift the lighter counterweight. And the system can even generate electricity in a process called regenerative braking. So, what about safety? People always worry about the cables snapping. Well, first off, it's not just one cable. An elevator is supported by multiple, super strong steel cables, each of which is strong enough to hold the car on its own. The chances of all of them failing at once are incredibly slim. But even if that were to happen, there are multiple safety systems in place. The most famous is the safety brake, invented by Alicia Otis way back in 1853. Modern versions of these brakes are built into the elevator car itself. If the elevator starts to move too fast, a device called a governor triggers powerful brakes that clamp onto the guide rails on the sides of the shaft, bringing the car to a safe and abrupt stop. There are also buffers at the bottom of the shaft, kind of like giant shock absorbers, to cushion the car in the unlikely event it goes too low. So, the next time you step into an elevator, you can appreciate the elegant dance of physics and engineering going on behind the walls. It's a beautifully simple system of a car, a counterweight, and a pulley, all working in perfect harmony to make our vertical travels safe, quick, and remarkably efficient. Thanks for watching. If you found this interesting, don't forget to like this video and subscribe for more deep dives into the technology that shapes our world. See you next time.